Hello and welcome to week 14 of the Beginner Boost. I'm sorry for the delay. You can go watch the other videos. I knocked my front teeth out. I was in a pretty serious bike accident. News at 11 or whatever. You can go look that stuff up on your own. But that's the reason I haven't been doing the boost the last couple of weeks. I'm sorry for that. And it's the reason that I can't say THs and Fs right now. I have no front teeth. All I want for Christmas is my two front teeth and a not broken nose. But it's quite the drama if you want to go read about it and watch it. It's pretty interesting. But if you're here just to learn the terminal, you're in the right place. So let's go back to see what we're back to doing today. Um, so I scheduled kind of an entire 2 hour session to just focus on finding files and vulnerabilities like a hacker. And I can't overstate how valuable the find command is, but there's a number of other commands that are related to that we're going to learn today. So let's just go through and kind of summarize what those commands are. One of them is going to be the find command, right? And we're going to do the file command. And these are also some of the commands that are critical to use when you are trying to pass any kind of like I don't know, over the wire comes to mind. Over the wire bandit. They want you to find files and look in them and see what they're about and everything, right? Um, we're going to do chmod. What else? Type, and we're going to do command. We're going to do a which and path again, which we've already done before, but I want to do that again. I think does this one have once? Once is on Windows, so that might be worth learning, but no. We'll do which command. We're going to do all of these. We're going to cover, and when we do chmod, we're going to cover octal. So, what are bases? Are your base? What are bases? And we're going to do binary, octal, hexadecimal, decimal, and base 64. Did I spell that wrong? How come I can't spell today? Decimal and base 64. Okay, so there's base 32. There's a bunch of other ones we're going to cover. So we're actually going to spend quite a bit of time talking about bases because chmod is the first, chmod, change mod, whatever you want to call it, is one of the first commands that really gets into this kind of thing. Now, you don't need, I always struggle with this every year I do it because you can use chmod without learning octal and binary and all that. But it's kind of a good segue into learning it. We're going to actually write some code that uses it. We're going to write our first script today. And then actually I wanted to show you this. So pretty much the rest of the beginner boost is coding. So, we've gotten used to using all of the tools and introducing, network HTTP and TMOX and Vim and all that. And now it's time to start creating a tool set, a toolkit. And we're going to get really heavily into that next week. But today we're going to write our very first tool or two, okay? And I always struggle with this because we haven't really organized our Git repos yet. We're not going to get into that today. We're just going to write a script and call it a day and put it in your home directory or whatever, and then we'll move it all later. We'll probably do that next week. Next week we got to cover dot files and all that jazz. All right, so this is where we're at today. I'm blowing out my candle. It's making me sneeze. So yeah. So being able to find files where they are, understand ownership and permissions. What are all the different types of ownership and permissions? What are the different types of files? And that's all stuff that we've kind of covered so far, but not completely. So let's jump right in. So the very first command that we're going to learn, and this is one of the commands that everybody learns but nobody masters. You can usually tell how good an engineer is by how well they understand the find command. And I really truly believe that. If when you're in your travels and you run into people, they might know, LS and stuff. Let's recover LS again, right? Obviously you guys know LS, right? And we should probably cover LSOF. Let's do that one too. I know this seems completely random. It really is. So let's actually, before we get into find, let's revisit what. Oh great, I always do a find. Yeah, and there are a few idioms we'll say. An idiom is a thing that you frequently use. Um, but what's the big deal, right? So you should be in your VM by now. You know how to fire up your VM and everything. I'm not going to do that for you. I'm running Linux on my desktop, which is another thing that I changed to in the last 2 weeks. I put Linux on my desktop now. So, and by the way, we are going to forgive the dog in the background. Um, we're going to be in the beginner boost next year. We are going to actually go over how to install Linux on hardware, and that will be a normal part of the beginner boost every year. And we're going to show you how to do that, how to install it into a virtual machine, and how to install it onto a piece of hardware. And I now have all the stuff to help you do that and show you how to do that. So, but for now, go back and watch the videos where it has you putting it in a VM. If you don't have a VM, pause the video right now. Go back and get the video that shows you how to start up your own virtual machine, and go start from there. Okay. Your terminal might not look as pretty. It might not have the customizations that mine has, and we're gonna get there. The reason we haven't gone through my Bash RC, if you're anxious and you just want it right away, you can go into my dot files on GitHub, github.com/rwxrob/dot, and you can go into the directory there and look for dot bash rc. You can copy that over right now if you want the fancy colors that I have and everything right now. But if you don't want them yet and you want to build your own, that's fine too. So the topic of the day, though, is files. Files, finding files, not necessarily file system organization. We already kind of talked about that. We are going to kind of touch on it again, though, because that kind of is a way of knowing how important the file is and what type of file it is. So let's start with the command that we already know, ls, right? ls by default shows you all the visible files. Well, by the way, this is a little review. Pause the video. What is not being shown here, and why? Pause the video. Give yourself a little test. If you answered invisible files that begin with dot, that's the right answer. How do you get it? How do you pause the video again? How do you get it after this question? How do you get it to show all the files? You should memorize this. How do you get it to do that? Pause the video. ls-a for all, right? So there's all this stuff. I know this seems remedial, but we have to go over this again. So here you can see that I have one file that's been hidden. I also have two other files. What the hell is going on with these things? Pause the video again. We've already covered this. We pause the video. Just take a moment to describe what these two, what's the dot mean and what does the dot mean, and why are those listed in my file directory? These, okay, here's the answer. The answer is that this is the dot actually represents the parent directory, one above, and the dot directory represents the current directory. And believe it or not, these are actual entries in the inodes table of the file system. So there's a thing. A fun fact as well. I believe it's under, I want to say 4 bytes. No, I want to say 1K. If a file is under a certain threshold in size, I can't remember the exact size. If somebody wants to look it up for extra credit, that'd be cool. The file itself is not created. The file itself actually gets stored internally inside what's called the inodes table. And the advantage of that is by knowing that, you know that by keeping files small, so say you have configuration files, right? 1 or 2 lines or something like that. Those files actually don't ever get separately saved as a file. Those files are actually saved in the inode table of the directory, which means there's no additional IO to open the file. So the moral of the story here is, when you're dealing with files, don't be afraid to break things up into smaller files of very tiny size because that will work well with the operating system, with the file system. Um, you may be tempted to like put all of that into a single configuration file and parse it with JSON, and that's perfectly fine too. But by doing that, you're incurring a lot of I/O overhead to open up that big huge file and then parse it all up. And I mean, it's microseconds, milliseconds, so it's not that big a deal. But just know that there is a difference there. There's actually somebody on Twitch that told me about that while I was streaming. They said, yeah, they said that within I wish I remember the number. I don't remember, but under a certain threshold of byte size, uh, the file is actually saved inside of the inodes table, which is really cool. So what is it we got here? I got a lot of files and they're different colors and stuff, right? And so let's actually review the ls command again. -l gives you the long listing. You should know about this. Now, when we did the ls command the first time, we kind of skipped over this, and I didn't talk about what was here. And the reason for that was because it's too big a deep dive into, what are the properties of a file, what kind of files that we have, and all that. And we can now go into that. We're now going to deep dive into that. Okay, so we've got 45 minutes left of this hour to go through here. This stuff, I'm going to try to make it as exciting as I can, but it's really not exciting. It's just, you just have to digest this information. Okay, so here we go. We have RWX, and if you're wondering where RWX Rob came from, that's it. RWX, it stands for read, write, execute. It also stands for a lot more things like read, write, explore, research, report. I've used the RWX as an acronym for lots of different things in my life, and so RWX Rob just made sense. I am rather flattered that several people have added RWX to their names as a prefix. Some people have asked me if that offends me. Absolutely not. I appreciate you doing that. That's cool. Um, so that's where that came from, and it's kind of blossomed into a lot more. Um, and I use RWX to refer to my community, the RWX community, as opposed to just me. So that's perfectly fine. The RW stands for read and write, and you can probably guess that means a file can be open for reading and it can be written to by who? Well, that's where this comes in, right? So there's 3 different groups, there's 3 different octets, and you get, this is the owner, okay, and this is the group. And I know that sounds weird, but by default on Linux anyway, all users also get a group that matches their name. So kind of by default, if you wanted to give somebody on a multi-user system, which I realize are very rare now, but on a multi-user system, if you wanted to give somebody access to all your files without actually doing that, you could add them to the RWX Rob group. And I've debated a lot about whether I should show you how to add people to groups and do group management and all of that. And we are not going to cover that in the beginner boost. It's very hard because there's a line kind of between using the terminal and becoming a terminal system administrator, right? And to give you a sense of that, like when you are installing software, you're kind of doing administrative things, right? So you're an admin on your own machine. So knowing sudo apt install, is a thing you have to learn. And all of user management, creation of user directories, that falls under system administration. And I really struggle because I mean, if I were to actually go into that, we would be here forever. But if you want to get into hacking or system administration, clearly you're going to have to go there. For the record, by the way, that content is still on the agenda. It's just going to be stuff that I cover under Home Lab Init. Okay, so as soon as I can get a really solid beginner boost done, and I can start moving to do these other educational courses, Home Lab Init will be the one. And Home Lab Init, it covers system administration. It covers system hardening, which means like making stuff so you can't break into it. We're going to show you a little bit about how to keep your system from being vulnerable today, but we're not going to go into hardening your whole system to avoid attack and things like that, shutting down services and stuff like that. That is not a beginner boost topic. But as with everything in the boost, I at least want to mention it so you know it exists. So if you want to run down that rabbit hole now on your own, awesome. And there are people who cover it on stream, Hetanis and a number of others. They get into the details of that kind of thing. But in the beginner boost, we're not going to cover it. Okay, so um, and home lab init will include, uh, installing Podman or Docker, container engines and Kubernetes and all of that jazz, and setting up your own firewall, and when you would use, BSD or OpenWRT, all that fun stuff. Eventually, that'll come there. So anyway, so we have the user Artifacts Rob, and we have the group Artifacts Rob, and you can probably guess that these three permissions here apply to the group. And it's not completely intuitive. So you can actually do some interesting things here. So, but like, for example, if you take away all the permissions from a group and you put somebody in that group, they can't see it. So you can actually use it to blacklist people as well. And I'll let you try to experiment with that. I mean, it's not a really important thing. It's just kind of interesting. And then this last one here is the world or other or all, right? And if you want to revisit what all of that stuff means, and we're not going to talk about this little guy here. We're going to talk about him eventually later. I'll show you. But then over here you can see we have so my by the way, type ls, right? So see my ls, we're learning the command type. Okay, type is actually a keyword for bash and shell. It's not a command. It tells you what type of thing it is. So the ls command that I use is actually not a command at all. It's an alias. And what it does is ls-h. And that's what gives me the 7.4K. If I wanted to use the ls command without using an alias, I could do ls with a slash in front of it. Did you see that? I learned that on Twitch, by the way. Yeah, I learned that in the first year I streamed on Twitch. Somebody showed me that. Been doing this my whole life. I never knew. So when you do that, what does it do? It takes away the alias, and it uses the ls command as is. And so now you can see I don't have any color. And if I do a long listing, you'll see now that I get these, the number of bytes. I don't even think it's bytes. I think it's blocks, actually. And actually, to learn about it, we can do man ls, which you already know. So we can do man ls. We can read all about it. In fact, I think the -l explains it to you. Let's go look for it. Where is it? The use of the long listing format. I mean, there's just so many options here, and we're not going to cover them all. You never really can cover them all. I do use ls-1 a lot because that forces it to be one per line. That is very useful when using the entr command, which runs a command every time something changes. Did I teach you entr already? We need to teach you entr right now. If not, I need to make sure you learn this. I do not want to risk you not knowing entr. All right, so it's kind of out of place here, but I don't know. I mean, I guess I could teach you entr when we do Go coding. Yeah, let's do that. I'll teach you that later. Don't worry. Don't worry. When we do shell scripting, we'll do it for shell because we're going to use shell check. Okay. I know. I'm kind of all over. I'm sorry. It's just normal. All right. So here we go. So the size of the argument integer is optional unit. Example 10K. Units are, here's all the different units. Powers of 1024 or kilobytes. Mebibytes and kilobytes. KI, there's actually K. You guys know the difference, right? So KB is like powers of 1,000. KIB is like powers of 1024. Why 1024? Because it's a base 2 number. And we're going to get into that in a bit. So the takeaway from this is very simply, if you want to get the real thing, you do ls, but you can add an alias to your bash RC right now. And if you want to add an alias to your bash RC, you can open up your bash RC right now. Don't have to wait for me. And you can add the same one. So if I go find my aliases, okay, what am I doing? I added screen key up in the top so you can see what I'm typing. So also, right? So here's my aliases. You can go down here. You can see all of my aliases. I just did a Control L to unsearch so that the red went away. And you can see all my aliases here. Here's the alias I have. If you want to add that line, you should know how to edit files by now. We went through Vim. So you should be able to edit that file in your bash rc file in your home directory, and add it. Pause the video and go add that, and then you got that alias, right? You can use that alias. Um, and you see another alias I have here, chmod, schmox, split chmod plus x, because I'm always typing that for lots of reasons. There's lots and lots of other fun stuff here. So that's enough about that. Let's do now. A lot of by default on a lot of systems you can use LL. I've actually disabled that. I don't like that. People will alias LL to be ls-l. It's very common to do that. If you want to do that, that's fine. I don't. So here is the size of the file in bytes. In this case, it's k bytes, which in that case I think is I think that's kilobytes or yeah, 1024. It is a default alias on Ubuntu. Yeah, it's kibi bytes or KIB 1024. This is the date the file was last modified. This is not the date that it was created. So it's probably important that we talk about this right now. Every file has 3 timestamps associated with it. And I'm going to go ahead and put that in here so I don't forget. So there's 3 dates. There's the A time, the M time, and I think it's the C time. And the reason this is going to, well, we're going to talk about these when we get to find. These are actually documented in the find command. So if you go to find and you just search for time, you'll find them. So yeah, see if I can find an exact presentation for. There we go. A min, A time, C min, C time, M min, M time. So A is the last access time. C is when it was created, I think. And M is modified. And that's the one you want, because that's when it was changed, not created. I mix those up all the time. Okay, so you have the access time, which is almost never useful, because if you even look at the file, you have like an A time, right? Modified is the most valuable, when it was last changed, M time, and then the C time, creation time. That means that's how old the file is, right? So this is going to be very important, because let's say, for example, you get hacked and you want to look for all the files on your system that have been changed or accessed since a given timestamp. Then you can use that, right? You can actually, with the find command, you can have it point to a file and use the date on that file as your benchmark, and say, okay, anything that's older than this file. And one of the things that's important that you learn about now is now I think it's important that we revisit the touch command. Now, you've used the touch command for lots of reasons, but not the reason you probably think, right? So we've been using the touch command. So let me show you. So ls-l. So this says July 29th is the last time that file was modified, right? And that was a while ago, right? It's 29th. It's just like August 29th, right? You can tell that this file is relatively recently is modified, right? Been modified now. But what if I want to change the last modified time on a file, because I'm for some reason I want it to look like it's been updated without doing anything? Well, that's exactly what the touch command does. So we already learned touch as a method of creating a new file. So I can always go, touch. So let's see, ls new file. You see there's no new file. And if I touch new file, it's a great way to create a file in the place you are. And that's actually a really good habit to get into, because when you're creating a new file that way, I've already talked about this many times, so I'm going to talk about it again. It's so important. When you're getting into system administration and file creation and stuff like that, very frequently, particularly if you're relying over the wire or something, you'll be on a system that you don't even have write permission to the file system. You can't create new files, right? So let me give you an example of this. I'm actually going to show you this because this is a really big problem. So let's say you're in Etsy, right? And you're in there and you want to modify a file, or you want to create a new file. So do I have an MOTD in here? I don't have an MOTD. So let's say I'm making a message of the day. I don't have one. I mean, that's not where it would go anymore. But let's say I were, right? So I'm in here as me, and I have a point here. I promise. That's why touch is a valuable command. So I want to make a new MOTD. So I do VI and I open up my MOTD file, and I say, hey there, right? And I save my file. Uh-oh, whoopsie daisy. Now what do I do? All right. Now what do I do? Let the greater than sign for create new files doesn't work everywhere in Maluba. That's the only reason I don't tell people about it. It doesn't work on some shells. I don't think it works in Alpine. We could go try it. Touch works everywhere. But otherwise, I use that. I sometimes use that. So you see the problem here? The problem here is, let's say I didn't just put a simple sentence in there, right? And if you're just learning VI, you're like, oh damn, I'm gonna lose my whole file. What do? I don't know what to do. Pause the video. What would you do right here? Pause the video. Pause the video. Don't come back until you know how to get around this situation. All right? Okay, now, the answer is this. If you get into this kind of emergency, you need to save this thing. You don't want to lose all your changes you just spent making, right? So this is what in VI, this is what you can do. You do :W to write, and you write it to temp, which everybody has write access to. And you're like, say, some backup, right? And now it's written it out, and now you can close it, right? It says, oh no, I can't close the file for writing. It's because it's still trying to write it in that original place, right? But now you can very safely say :Q exclamation point, which does what? Pause the video. Okay, pause the video. What does it do? Question exclamation point. What does it do? It closes without saving. So do I have an MOTD file here? No, I don't. But where do I have one? lstemp/some file, right? Some backup or whatever I did. What did I call it? Backup file? Some backup, right? And I can cat my temp some backup and you'll see it. Some backup. There are my files there. Okay? So that's how you get yourself out of trouble. Now, enter touch. Enter touch, right? If you get into the habit of making new files with the touch command, you will never, ever have that problem. Let me show you. If you go into Etsy and you're like, and your regular routine for making a new file, you do ls to see if I have an MOTD. Like, oh, I don't. Okay, I'll make one. Touch MOTD, or as somebody said, on some systems, not all systems, you can just do a greater than sign. That doesn't work everywhere, so please don't. You can use that if you want, but I just learned touch. Touch MOTD. Uh-oh, can't make it because I'm in the wrong place. And so I'm like, oh, I'm being dumb. I need to be root now. And now I know to go be root, right, first. And then I can sudo su dash, or I can just sudo su even. I know my super secret password. And now I can touch MOTD and ls-l MOTD. And you see that you got, oh, it's owned by root. And now I can edit my file, something, and save it out. And I'm good to go. Right? So why is there no make file versus make dir? Good question. I don't know. You can make one. You could make an alias. You can make an alias for yourself and make it alias to touch, because that's what touch does. So touch has two purposes, right? And I got to get rid of that file before I forget. Sudo rmmotd. All right. So, and I did that without, you see how we haven't learned sudo yet, really, but so that was kind of a long-winded way of telling you why touch matters, right? And I strongly recommend following that, because that will save you a lot of headache later. But the other thing touch does is it updates the date timestamp. So, and that's what got us on this topic. So here we see it says July 29th, right? But if for some reason I wanted to change the modified time, I can do touch readme, and then I list it again, and you can see that it's now August 19th. Be careful. You can't go back. After you do that, you can't go back and actually, I think you can. I think you can actually change. What would it be? God, I don't even know what would it be. There's a command. I don't ever do it, but there's definitely a command you can use to say, I want to change the date on this file to some other date. I don't know it though. I don't know off the top of my head. I don't use it ever. Is it touch-date? Is it really? You guys are so good. It's touch dash date. You guys got ads. I'm so sorry for the ads. I have no control over that. So, okay, yeah, look. Okay, so you can go ahead and put the date on it. You could actually, now that's kind of cool. As a hacker, can you think of a way you could cover your tracks with that? Yeah, you could. You could cover your tracks. There's some things you could do with that command to cover your tracks, if you actually were on a system interactively. I mean, there's other things you'd have to do, obviously. Uh, but yeah. Anyway, so there you go. There's touch. There's touch and LS. We reviewed LS again, and let's go back to the long format. Okay, so the color over here is generally consistent with the type of file that it is, right? And the permissions on the file. And we have not covered this, and I don't know when to cover it. I think we'll probably cover it when we do the bash RC. When we go through the bash RC file, I don't know where to put it. I don't know where to put it, my friends. Don't let me forget, though. Add dir colors. Okay. So if you want to go ahead and do it now, you can. So in my dot files, there's a file called dir colors. This is the colors to be used in the ls command. I think we may have actually covered this when we covered ls a long time ago. But if you want to have the same colors as me, just go copy this file. I copied mine from somebody else and put it in your home directory. All right, and this will show you the colors. You can actually use it to change the colors of the different types of files that you have here, and it is a part of, the ls command if you want to get colors, and that's what this is about, right? This one is red because it's an executable. That means it can be run. This is actually a script. It's not just a file. It's actually an executable. That means it's a script. In this case, it's a script. That means it's a text file that can be run as a program. Same with weeks here and stuff. Okay, so we've covered the permissions. Now let's jump in to Octal right away, since we're talking about files. I don't know if we're gonna be able to get to that one. Let's we did ls and touch. Let's do chmod. We already did type, right? Let's do type and file really quick. Okay. Let's do type, file, which, and command really quick, because chmod's going to take a long time and fide's going to take a long time. These are pretty short. So type. You already saw me use type, right? What is type? Type tells you the type of thing it is. So ls is a thing. Type readme.md. Okay, now type is only for commands. So don't confuse it with file. I do that all the time. So file shows you what type of file it is, and type shows you what type of command it is, right? So they kind of go together, but they're not the same thing. So type looks through your path, anything that you can run as a command, and it sees it's not really related to this file conversation, but I do want you to see that's what it is. And then the last command related to this, file type and which, they kind of go together. Which. Now, this is actually wrong, right? So which shows me that this is the file in my path. You guys remember path, right? This is the file. This is the ls program that first occurs in one of my files in one of my path directories, right? User bin ls, right? So if I put, just a reminder, we covered this, but it's a reminder, if I have an ls executable, that means it has execute permission, which we're going to get to. If it's executable in any of these other directories, it will win over this one. That means it has priority and it will run. And as you can see, I put a lot of local things inside of my bin. I actually, for example, my links command, you'll see, resolves to my scripts directory, right? But there is also a links in, I think it's user bin links. User bin links, right? So this is the actual links binary that gets executed. And how do I know that? Let's use file on that. File. That'll show you it's an ELF binary. It's a compiled C program. And you're like, well, okay, so pause the video. I'm going to ask you a question. When I type the word links and I hit enter, what program runs? A, this program in my .scripts links directory, or B, this program and user bin links. Pause the video. Unpause. Okay, the answer is both. Yeah, I know. You weren't expecting that, were you? Because why? Because the scripts directory runs my links command, and then my links command, I'm kind of overwriting it. My links command is set up to say, I want it, the actual links is in user bin links, right? And so I covered this when we did links last week, but, or was it 2 weeks ago? But what this does is it sets up a number of things in the environment variables, and it makes my links look like a Macintosh so that it works. Otherwise, it'll get blocked as hackerware by the web servers out there. And then it runs it, and then it runs the actual links. So if you don't understand what I just said, pause the video and digest that very carefully, because it's super important that you understand that. It's super duper important. Okay, pause the video again. I have another question. Here we go. As a hacker, how can you take advantage of a user's misconfigured path? Pause the video. Okay, the answer to that is you can do what I just did with links, except you can be nefarious about it, right? So if you managed to put, I don't know, a command like passwd, which sets the password for a user, right? If you were able to put a password, a passwd script in the user's path ahead of the one that is actually normally used, right? And they didn't know, they could run password, and as long as you pass the command on like I do with the links command, they'll never know. And you could write out all the passwords to some kind of encrypted secret file someplace, and then when you get back on the system, you don't even need a keylogger. You can just go in there and look at all the stuff they've been put. It's like, what do we get here? Because now you've just Trojan the system by putting something in their path, and the system never ever looks at which password's been run. They assume that it hasn't been affected, right? Now, there's obviously much. If you have that level of access, you should probably just install a keylogger, and you can see everything that any user types on the entire system, and that's usually what a hacker would do in that case. They usually wouldn't go to the trouble of like putting something in front of the password. But it's important that you understand this, because as you are creating software, you need to be really, really careful about where you put executables and how you name them and what order they come in and which ones show up and everything. Because, you know, you could very easily troll an admin into doing the wrong thing. And it's something that's kind of interesting. I mean, you could, if you knew somebody, if you want to troll an actual system admin who's got root, you can have them come over and say, hey, I screwed something up. Can you help me out? And then you can deliberately, in your own user account, you could put whatever in there, right? And then they'll type sudo, and then you can just like read off all the stuff that they type in. You could like get kind of creative with your social engineering. I'm not telling you to do that. I'm just saying that you have to be aware of that, because that's a very real possibility if somebody's doing that to you. So you have to know what path is and what type of file it is, right? So how would you protect yourself from that, right? Well, I would do this. I'd say, which links am I using? Oh, I'm using this one in here. Oh, interesting. Well, how do I know what type of file it is? Now, you don't know this yet, but I don't think you know this, but I'm going to show you something else. I want to see what type of, let's combine the commands. I want to see what type of file that is. So file, which links. Now, pause the video and make sure you understand what I just did. What did I do? What I did was, instead of typing out this big long thing here, I replaced it using backticks. And another way to do that, if it's actually going to be in a script, is this. Exactly the same thing. Those are backticks. We're going to learn that when we start bash scripting, but you might as well start using it right now. And by the way, you can probably guess what VIC link is. Can you guess? Can you guess what's inside of that? I bet you can. Pause the video. What do you think is in my Vic? You can probably guess. When I type Vic links and it opens up the file at the right place, Can you guess what it's doing? Watch this. VIC. What this does is it opens up the command at that location. So in addition to which, there's one last command in this type of command set that we're going to do. And its name is command. The command's name is command. And command, as you can see, is a built-in. It's a shell built-in. If you do which command, you'll be like, I don't know where it is. That's because it's not a binary. It's not an executable. It's a built-in. That's why you use command type, okay? So, and by the way, when you want to read about things that are built in, there's no man command for them. So how do you look them up? Pause the video. You should know this already. Help command. So bash has a help command built in to help tell you about the built-in. And what that does is that grabs that section of the man page and just shows you that specific section only. That's what the help command does. So if you run into a built-in and you're trying to figure out how to use it, just know you're either gonna use help for that. So you're using pretty much man or help for everything, right? Otherwise you're searching the internet. And immutable root won't save you. No. All right. So yeah, there's so many things you could do. People are getting really creative in the chat about what they could do with path variables. So that's what command does. Now, I was probably, I want to say I was like 45 before I realized that in all of my shell scripts, I used to type. I would type. I would say something like type links, right? Or I would say which links to tell if that command existed. And the actual proper way to tell if a command exists on the system is command-v. And this is hands down the most standard way to tell if a command is a command on the system. So that little command-v that we did, you might want to memorize that one, because when you're writing code, then you need to check if a binary or an executable exists on the system, and that it's, that command-v will, I think, only works if it's an actual command. So like if I were to do an alias, so command-v ls, you see this? It tells you that it's an alias, but it still tells you that it exists. So if you want to do command will say that command will return success if something that you're using could be used as a command, period. Whether it's an alias, whether it's a function, or it's something else. And sometimes you want any of those conditions, if they're true, you're like, fine, they've got this covered, right? If you want to be really sure whether the binary exists or not, then you would use which, and you would do, which ls, and that would be sure to tell you that the binary has been installed on the system. So those are some tricks about, where the files are and how to deal with them and everything. And if you want, you can read the source code of VIC to see. So what this does is it takes the first argument. That's a mistake, actually. This should be shell check is yelling at me. I'm going to fix it right now. There we go. So this says get the command for the first argument. So in that case, it was like links or whatever. And then it says, all right, put that in a command. It says test-n to see if that command is there, if this command has anything in it. If there's nothing in there, then it means if the command is empty, then don't do this. But if it isn't empty, there's something in there at all, then go ahead and execute vi at that command. And this would execute the vi command and send the name of that command to it. Now, I realize now that this would probably have a problem, because I don't know if it's going to work for ls. Let me try. I think I might have a bug. Oh, no, it worked. Yeah, so that actually opens up the executable and gives you the real command. Yeah, interesting. I don't think I knew that. Yeah, that's very cool. When it was used in that context, it actually gave us the binary file instead of the alias. Wow. I just learned something. I didn't know that, because I was expecting it to be that right there, and that would not be the right thing, right? So that's cool. Anyway, I know we have 12 minutes left for this first hour. So ls touch type file which and command, those you should know how they work now, right? File is super important. File tells you what type of file it is, and it's extremely intelligent. Um, and I mean, it's been the product of several years of development, and it will tell you exactly what those things are. Um, and that is the answer, by the way. Using file is the answer to several of the challenges on over the wire, the hacker challenges. It tells you it's ASCII text. I mean, you can find out a lot of things from this, right? It's not always accurate, though, by the way. So, like, if I do /proc, let's do that. Let's do something in here, shall we? Should we get crazy? We get crazy. All right, so let's actually look at some other files that are really weird. Let's go, come with me, if you will, into your dev directory, the home of crazy files. Now, don't get too crazy in here. Don't be like doing things as root in here. All right. They're like, what is going on with all these colors? Little story here. I once got hacked, and the hacker built a rat's nest rootkit inside of the dev file system because they thought it would be hidden, and I wouldn't see it. And I caught them because I ran a tripwire process that caught their new file, and I was like, this is not a device file. This is something else. And they had something like PTSX. That was it. They do something like PTY or PTS, and then they added an X to the end of it, and that was their rootkit directory. And they were setting it up, and they were getting ready to hide it from me and everything. And I caught them, turned them in. So if you go to, so here's where the file command comes in kind of nicely. Like, so if you do ls-l and pipe that to more, because there can be a lot. Look at all these crazy things. What is this about? We covered this already. We looked at this, but and if you want to read all about these, I think if you do man ls, I think you could probably figure out what most of them actually mean. But between that and the chmod command, which we're going to cover right now, you can see. So the one of them we've already talked about, and that's this one. And God, we need to cover symbolic links, don't we? Damn it. I didn't want to, but we're going to have to do that. We're going to have to cover ls and ln. We're going to have to cover ln. I didn't want to cover ln, but we're going to have to cover it. So we'll come back to that. I think they're probably not inheritance script aliases are probably not. I think so, LBG. I think you're probably right. So the D stands for directory. That's probably obvious. But you can see here's the ownership and everything. What's this number about? Anybody know? We're going to come back to this number. This number is the number of hard links to a file. And we'll come back. I think we may have covered this already, but we're going to cover it again because it's really hard to understand. And then we have the L, right? If your font doesn't have a curly on the L, I strongly suggest changing fonts because it'll be so hard to distinguish it from a 1. It's really annoying. So there you go. There's an L, and this shows the link pointing to proc kcore. So this is what's called a symbolic link. Symbolic links, as a strange fact, are always full permissions, which doesn't really make any sense, does it? It's like anybody can see a symbolic link on the system every time, but it still doesn't mean they can read that thing. In fact, if you want to see whether or not they can read it, the symbolic link itself is like world readable, right? And you would think that it could be removed as well because it's read, write, execute, right? But it can't be for some reason. I don't really understand why they did that, but that is just the way it is. And if you look at proc core, kcore, you'll see that the actual permissions on the file to which it is pointing are just read only, right? And that's a good thing because that's your kernel. I mean, can you imagine somebody coming in there and just like deleting the kernel? And as people like to say, everything in Unix and Linux is a file. Everything is a file. And that includes the kernel. The kernel is a file. Every configuration parameter for your entire system is done by changing a file. Even if it's not really a file, right? And that gets complicated, but a lot of the stuff in dev can be changed through different means. And a lot of the commands that we actually use from the command line, that's what they do. They manipulate the system through /proc or /dev or any of the file systems, pseudo file systems, which are not really files. They're things that look like files, but that actually communicate directly with the running system. So that's the paradigm that Unix has taken, is that if you want to communicate with the running operating system, you're gonna change, files, pseudo files, and then you see a bunch of these things. So C, these are special. These are special devices that are not real. And here's the min number and the nine number. I'm not going to get into this, but these are not real files. They are settings, right? So you can actually cat these things. Be careful you don't actually change the values. You might end up reconfiguring your thing. Let's do a sudo there. My super secret password. So you see there? That's the current setting. So if you wanted to change that setting, you could actually, since you know how to change files in place, right? You could actually cat a new value onto that file, and that would change the setting. And it's actually pretty common to do that. It's a little bit tricky to do that, using your command line, but you can. Most of the time, that would be done through some other program, but you can do it. You can change things directly by catting them like that. But the reason that we're here mostly is I wanted you to see that these files are kind of weird, right? They're very special, and they still have timestamps, but this is different. The reason this is like this is because it doesn't have a size. There's no actual file there. These are the addresses. I think it's the min address and the max. I can't remember, but these are addresses to a space in memory relative to where the kernel is. Just know that they exist, right? If you're a hacker, if somebody's got their system misconfigured, you might be able to change how that kernel is running in runtime by changing these values. You can go in there, if those things are not protected, you can go in there and change the values of how the kernel's running by messing with it. So just be aware of that, and that exists. Okay, so that was the only reason I wanted to show you that, because I wanted you to see that there are different kind of files. Let's take a moment to do ln, since we just did it, and then we'll do chmod. Chmod's going to be a big one, so that's why we got to do octal. All right, so the ln command is just a way of symbolically linking, and I'm almost positive we did this already. Okay, so let's say that let's say that I'm somewhere else, and I want to, we're going to do this again when we start to set up our bash RC file, right? And let me actually show you this. So if we look at my home directory, you'll see that my vimrc is actually not there. And when we start doing our dot files next week, we're going to come back to this. But as you can see here, it's got this file is actually pointing to this file in my Git repo. All right. And the way you do that is you just do ln, and you can read about manln, you can read about it's a command. I always forget which one comes first. But if you do ln, and another thing you probably want to get used to doing is pwd, because you usually want it to be the full path. If it's not the full path, you might get problems. You can even put that in quotes, pwd / quick. Okay, we'll say quick, right? Quick pwd. Oh, get rid of that. You don't want that. Now I want to link that to temp blah. All right, so now if I do ls-l on temp blah, we see that it's a file, right? And that the file exists. I actually did it backwards. I always do it backwards. I always do it backwards. There we go. Update WSO blew up destroying Podman. Oh no, it worked. The link worked. Yeah, and I did it. I did a hard link instead of a symbolic link. That's why I got confused. Does anybody know what that means? Be very careful here. So don't do this to any files you care about, right? I don't want to blow away my file, even though it's in Git. So, but watch it. If I do ls-l, wait, what did I link it to? Quick. Okay, ls-l quick, right? Now watch ls-l temp blah. Notice anything different between those two? Pause the video. There's nothing different. Those are the same exact file. What else is interesting? This number's 2, right? So I did it. I forgot to put the S in there. So let's teach you hard links first. This is what's called a hard link. So these are two separate files that refer to the exactly same memory space, persistent storage. They are literally hard links that refer to the same thing, and they, you know, when you remove the one, the other one stays there, right? Because all you're doing is removing the hard link. If I remove temp blah, and now if I do the ls-l on temp blah, there's no blah there anymore, right? But if I do the other one, you'll see it is there. And now it's only got one here. Okay? And that means that there's only one, that file only exists once. There's only one link to it. But it's super important you know this, because somebody, I mean, security wise, you could go in and see that somebody may have made a hard link. What cases would you use a hard link instead of a sim link? Hard links are much better in performance. They do not occupy a separate entry in the cron job. Watch what happens if I do exactly the same thing with a symbolic link, and I think you'll kind of be able to see that yourself. So let's do a symbolic link instead. So let's do -s. All right, and hopefully I did this right. I didn't make any changes to quick, right? No, I didn't. Okay, so now let's do the same thing. ls-l quick.md should be the same, right? ls-l temp blah. And now you can see the symbolic link. It looks quite a bit different, doesn't it? Notice that it takes 70K, because the hard link does not take any additional space in the inodes table, right? It's literally an additional pointer to the same file, whereas this one is an entry, a standalone file. A symbolic link is itself, if you will, a file. A hard link is a pointer to a file. And a symbolic link, although it seems like a pointer to the file, is itself a file. It has size. Here we go. See that? It has a modification time of its own, and this one doesn't, right? These are just two different pointers that point to the exact same file in memory or on disk. And it's a symbolic link. You're actually adding a file to this. It's a special file, though. It's a link. It's a symbolic link file. Now, why is that important? Now, this is where things get really interesting. What happens if I move the file to which the symbolic link is pointing? To quicker.md. All right? What do you think is going to happen? Can you guess? Okay, thanks for the follow there. So what do you think is going to happen? Right? So the file's gone. Let's go list that file now. Oh boy. Now what do we got? Right? And if you've got your dir colors correct, you'll get a glaring reminder that symbolically link does not resolve anymore. All right? Copy hard links instead of copy sys links. Yeah. So as you can see there, that's a problem, right? Because what? Now if I tried to open temp blah, it's like it just made a new file. Now it's very confused, right? Now watch, if I put quicker back, it'll resolve. So I mean, it's one of the age-old debates about whether you should use symlinks or hard links. People have been arguing about this forever. This is a lot of time. I use symbolic links when I know that I'm going to be pointing to a file that exists someplace else, almost always. One of the things about symbolic links is that they do, if I remember right, symbolically links do traverse file systems. We haven't talked about different file systems yet, but let's say you have, a hard drive, an SSD, and you have like 2 or 3 hard drives on your machine, and you cannot have a hard link pointing to a file on another disk, but you can have a symbolic link pointing to that file. You also cannot move a file between disks. It has to be copied. if you try to do the MB command, and I know that seems obvious, but in Linux, it's not always obvious that a file doesn't exist at that location. It's not always obvious. Um, I'm sorry that it's on a different location. And that used to be a big problem actually with /temp, because /temp used to be its own temporary file system. It's not anymore. It hasn't been for a long time, but it used to be a separate file system. So if you wanted to temporarily make a copy of something, or you wanted to move a file into temp and then move it back, you couldn't do it. You had to copy it, right? And so that would be a case where you'd want to use a symbolic link. But let me do exactly the same thing now. Let's remove our symlink. Notice, by the way, that the hard link number didn't change, right? So we're going to remove temp blah. Let's go back and do it without the S. Here we go. We're going to get rid of the S. We're going to do a hard link again. And as you can see, temp blah is now got a 2. And so does quick.md. Quick.md has also got a 2. Okay, but now what? So now let's move the file. Watch what happens. Quick.md to quicker.md. What do you think is going to happen? Pause the video and guess. What do you think is going to happen? Is it going to change the file? Nope. Still the same file. So that's one reason you would want to do that. That's one reason you would want to do that, right? And I think it's important. It's worth mentioning that both of these ways of creating 2 of a thing can be used for some creative organization. And I wonder if I have time to show you this, but if you look at one of my favorite Linux operating system, it's safer to use hard links. That's up to you. I'll let you define that. I'm gonna let you make your own decisions about that. I think that there's good uses for both of them. But let me give you an example of this. So if you do podman run it dash remove alpine. Oh, that's right. I forgot. I screwed this up. I forgot. I have to fix this. Give me a second. I'm gonna go over here and do this. Okay, so podman run it rm alpine. So Alpine is an operating system that uses the BusyBox operating system. And if you go into bin here, this is actually really cool. If you do ls-l in here, what do you see in here? You see anything interesting? Isn't that amazing? This is what's called a multi-call binary. And this is a command. It's a very advanced topic, but I think it's fun anyway. I want to tell you about it. Every single command in BusyBox and Alpine is one command. And the command itself is written to understand how it was executed. So when it's run, it asks itself basically, what's my name? And it says my name is stat. And so it runs the stat stuff inside of its head. And otherwise it says my name is stdy. I'm going to run it. So all of the code for the entire BusyBox and Alpine Linux distribution is in one binary that fits on a floppy disk, by the way. Cool, huh? Isn't that cool? I think that's so cool. If you go, there's 2 different distros you can go look at. The BusyBox distro is another one. You go cd into bin, ls-l. And now you're like, oh, damn, they're not symbolic links. Now, why aren't they symlinks here? What's different? You know. System D developers take note. Exactly. So, look at this right here. What's different? Pause the video. There's no symlinks. What the hell? Now, this is kind of a fun rabbit hole, but it's kind of a bonus question. So, what is different? 404, symlink not found. Believe it or not, this is not a not found. This is the number of hard links to the same binary. So if someone were to ask you, what's the difference between BusyBox and Alpine? What is one thing you could tell them? In BusyBox, they used hard links, which have a limit, by the way. Hard links have a finite limit. Symbolic links do not. Symbolic links do not have a finite. You guys were asking me the difference between hard links and symlinks, and I'm giving you like lots of variation here, so you can make your own decision. So the engineers who made BusyBox, the original BusyBox, decided to use the limited number of hard links. I think the maximum is 512, I think. And they used hard linking to the same binary to get the same effect as they did with symbolic linking in Alpine. And so they don't run into, with the symbolic linking, they're not running into the limitation on the number of links to the file. So a lot of people don't know about this, by the way. There are many, many veteran senior engineers who do not know what a multi-call binary is, and now you know. And the reason I think it's important that you associate multi-call binaries when we talk about linking is because that's actually one of the best examples of using linking for a useful purpose, in my opinion. There's lots of practical need, and when we get into the bash RC stuff, we're going to be creating a single .files repo, and a lot of people love to, put down this approach to it. I still think it's a valid approach, but you write a script, and what does the script do? It makes a whole bunch of symlinks in your home directory that point to the files in your GitHub. And then when you change the files in your GitHub, you save them, and they get saved up on GitHub. But as far as your machine is concerned, it doesn't know where they are. And you would never, ever, ever in a million years, if you do this, just don't tell me about it because I will yell at you. You would never, ever, ever take your actual home directory and put that on GitHub. That is the stupidest thing ever. And I see people doing it all the time. If you want to hack somebody, go do a search for anything in their .config or .cache directory, because some idiot on GitHub has saved their entire home directory to GitHub because they wanted to put all their .files up there rather than picking and choosing the correct ones. And they've ended up saving all their secrets and tokens and passwords to GitHub. Don't be them. Don't be them. Now you'll know the difference. So creating a script that selectively creates symbolic links that point to files that are guaranteed to not contain secrets is the preferred approach. Now there's a lot of tools out there that'll take care of all that work for you, but you don't need it because you're going to be a scripter. You're going to know how to do it yourself. You don't need somebody else's tool. You're going to write your own tool. Okay? It's not even that hard. And then you'll be in control of it. I get kind of spun up about people that depend on fuzzy finders and all these other things when they could have just used find. Okay, which is a great segue, by the way. So we're gonna do chmod, and then we're gonna do find. But I'm gonna take a break because my throat is hurting me and my teeth are kind of sore. So I'm gonna take a quick break. So wait for a second here. All right, we're back from the break. We are gonna go ahead and finish up. We need chmod, find, and maybe LSOF. We really don't need LSOF. We don't need it. Not a beginner doesn't need it. So if you want, about it, go look at it. You can go see LSOF. Matt, let's do it in like 20 seconds. List open files. All right, so it's a way of listing all the open files on a system and what processes are using those files. So that's kind of nice, right? But that's all I'm going to say about it because you can get there forever. Sometimes that's useful when you want to see what a running process, what files it's using. And we haven't done anything about running processes. We're going to actually do that. We're going to talk about how to manage processes that are running and everything a little bit later when we do the toolkit. We're going to talk about managing processes right here. And at that time, we can talk about how to associate a running process with where it came from and stuff. All right. So, and that's a big part of like debugging and hacking and all that. So that'll be a thing we do. Let's go back to chmod though, and let's talk about kind of the elephant in the room. Thank you for the follow there, which is how to change the permissions, right? And why you need to change permissions. So here comes the part where you're going to write your first script, right? So you got your directory here, and it doesn't matter where you are. You can be anywhere. And you're going to make a file, and we're going to turn that file into a script. So this is your first script. We're going to write hello world, and today can be your code birthday. It's a popular term I used to use back when I was teaching at SKILSTAK. So today, if you've never written any code before, today is your code birthday. Today is going to be the first day you're going to write any code at all. You can say, I started coding on today, and make sure you put that date somewhere. You will get asked that, by the way, later in life if you are, young and new to this. Later, like, how long have you been coding? I'm like, well, I can't remember really. You'll remember today. So let's do it. So the first step is to make a file. How do you make a file? Well, we already know that, right? Touch hello. Hello. All right. ls, and I got a hello. It doesn't matter where it is. We're eventually going to put it someplace else and back it up and all that. But for right now, we're just making a new one. Now it's just a white file, so we can see right now that the computer thinks that it's just an empty file, right? Well, let's put some random stuff in there, shall we? So let's echo hello, and we're gonna get Inception like this. We're gonna echo hello to the file. Yeah. Whoa, did that just blow your mind? We echoed echo hello to the hello program that then echoes hello. Did your mind just explode? Oh, and look at now. Now the file has got ASCII text in it. So our computer is telling us that it thinks that it's just a text file. And we can tell it's a text file. We can use cat. We can do text file. Oopsie. Hello, duh. And we could even do tac hello. And it's the same thing. Oh my God. Because why? Because it's like forward and backward, right? And thank you for the follow there. But I wanted to do my program. You already know the echo just prints out whatever you have there, right? So how do I make it run as a program? Well, it just thinks it's text. So the first answer is you can give that text file to a program that knows how to run it. Can anybody think of the name of a program that knows how to run a file that contains echo hello in it? Pause the video. Answer the question. What is the name of a program that is running, or that we can run, and we can give that text file to the program as a list of instructions, and it will run it? Right? Bash. If you answer Bash, that's true. Actually, there's another program in addition to Bash. So let's actually give that file to the program, right? And there's two ways to do that. One of them is this. We can redirect the hello program to Bash, and it runs it, right? Or it just so happens that Bash itself, the program, will take the name of a file. Either of those two ways will work. Do you know the difference between what I just did? If you don't, pause the video and see if you can figure it out for yourself. But the answer is, one of them is redirecting standard input into the program, and the program sees that standard input is coming into the program like a pipe, and then it does it. And just here's something interesting. How is that? I can do echo hello. I can do echo hello, and I can pipe that into Bash. What do you think is going to happen? Oh my God, what just happened? Make sure you understand what just happened, because this is a review of what we've been talking about with pipes and stuff before. Okay? It's the Unix way to do stuff in this way. Bash is set up to take in input and to run that as a program. The formal name for Bash is an interpreter. So make sure you write that down somewhere. An interpreter. And every time you think of interpreter, if you need a mnemonic device, some way to memorize this, think of C3PO. What is C3PO? This time I usually, cue video. I usually play a video of C3PO right now, right? What are you? Oh, I'm a protocol droid. What is your function? Oh, do you speak Bocce? Yes, it's like a second language to me. What is C3PO's job? C3PO's job is taking in information, protocols, and languages, and interpreting them so the humans can understand, or so the moisture evaporators can understand, what's being said. So what is an interpreter? An interpreter, in this case, takes our human commands, in Bash, written in Bash code that we understand as humans, and it's converting those things into syscalls. And syscalls are then that's binary. It's like kind of like the binary language of moisture evaporators, only this time it's not moisture evaporators, it's the kernel. And it sends those binary commands into the kernel that then processes our commands. Right? If we didn't have this, we would have to write assembly. We'd have to write, the kind of language that the computer understands. So an interpreter, it's the word of the day. The interpreter is what takes a script, which is a bunch of text, compiles that text or converts it, transpiles it. There's not any number of things that it does. Turns it into essentially instructions, and those instructions go into the kernel and they run. And it does it so fast that you don't know that it's happening. But it's still less efficient than compiled code. And we are going to talk about compiled code versus interpreted code later. When we look at Go and Python and JavaScript, we're going to look at programming languages, and you will be able to tell the difference between a compiled language, an interpreted language. It's a little bit of a trick question there because all languages are compiled, strictly speaking. Every single language is compiled. The question is whether it's precompiled, right? And in the case of, and you can tell the difference between scripts. So I don't want to get too far into the programming world, but you need to know this because as far as our computer is concerned, this hello program is just a text file, right? But when I send that text file to Bash, Bash is like, oh, you got instructions for me. Okay. And then it does it. Now, this is going to blow your mind. I mean, it still blows my mind. Every single line you type into the command line is an interpreted line of code that runs. You're already programming. And I did this before, but I'm going to tell you it again. You are programming. If you are using a command line terminal, you are coding. So that thing about your coding birthday being today, maybe. But the truth is, as soon as you started using a command line, you started coding. And I'm going to prove it to you. If you take the exact same things that you type on the command line all the time and you put them in a file, you have a script. You have a program. Watch. If we go to this hello thing, right? Let's actually add some other commands in here. Let's say hello. You can say echo, I see you are in directory. And then we could just do CD, which just shows you the directory. And the echo, which has the following files. I'm being really lame with my coding right now, but I want to make a point. These are the same things that you would type in the command line, right? Each one of these lines is an instruction that's going to be interpreted and sent, right? Now, what happens if I do that? What happens if I echo? Well, let's do this. Let's do bash, send. We're going to put all those lines. We're going to send all those things we're going to send our hello program into bash. Oh, wow. Look what it did. There's lots of stuff there, right? But it did it. You know what? Let's do pwd. All right. And let's just do a regular ls because it's too long. So there we go. All right. So it ran our program, right? By the way, you'll see people on Stack Exchange tell you to do crap like this. Don't you ever do this. Don't you ever do this, my friends. Unnecessary use of cat is one of the first and most prominent indicators that you're a noob. Don't do that. If you don't know why that's bad, why would you run an extra program for the same thing that you could have just done with a redirect, right? Hello, right? Or better yet, Bash actually understands the name of a command. It takes an argument, it's called, and it'll run it. Okay? Now, your next question is, Mr. Rob, how do I make it so I can just type hello and it just does it? Right? There's no hello program. I can't find it. Oh, that's because I forgot to put this in. Nope. Permission denied. Why? Because it doesn't know that it's an executable. It doesn't know it can be run. Why? How do we know that? Because when we do file hello, it says it's just a text file. I can't run that. And if you compare it, by the way, to a program that's not, so let's do like ls, right? We see, oh, that's an ELF binary. Oh, damn! Like, look at all that, right? Or if we compare it to a script, we see something different. You don't have a script yet, but if you did, like my weeks script, you'd see that it's, oh, weeks is a born again shell script. Oh, how do I make it that? I want to get it to be that. All right. Well, the first thing you need to do is you need to change the permissions, right? So when we look at the permissions on my hello program, it's just a text file. So the first trick we need to give a tip. We have to change the permissions, and this tips off our computer to see that it's not just a regular text file, right? It's a little bit more than that. This is actually something that can be run. It's not just a file. For our own safety, we want to get this X in there, right? And strictly speaking, we don't care if everybody can run it, but today we don't care though. So we're gonna do a very simple thing. We're gonna do chmod plus X, and what that does is it adds executable permissions for the owner, for the group, and for the world group, everybody. And so we do that, and we do hello, and that's now we get an ls-l hello, and we see that it's got the X on there. And now it's red, and when we do file hello, it says that it's still ASCII text. What the hell? What the hell? Now, this is where it gets kind of interesting. The file command is too dumb here. Let me prove it to you. Let's run it. Now, if I type hello, why won't it run? If you don't know, pause the video and figure it out. Why doesn't it run when I just type hello? Why not? Why is that not running? If you answered because it's not in the path, it's not in my path, that's the correct answer. It doesn't have to be a binary. That has nothing to do with it. It's an executable. It can be run. I'm going to prove it right now. The reason it doesn't run by just typing the name is because it is not in the specified path that contains our executables. And we covered that a while back, but we're gonna cover it again. But this is what this is right here. So if you can echo $path if you want to see the hard one like this. If you have the path command, you can go ahead and do that. By the way, here's what the path command is. Yeah, see path. If you want to add your own path command, you can, and you can take a look at that. But what that does is that just puts these all on its own line. But unless you put a binary, an executable, something that has had a chmod plus X on it, unless you put that inside of one of those directories, it won't run. And the reason for that is for our safety. We don't want anyone to just be able, even me, to be able to run these commands because we don't know that. So what that means is that in order for our safety, we need to use the explicit. Remember how we had ls-a? You remember the dot and the dot, right? So now, for our safety, if we do this, if we do /, that says that is a full path. It's a relative path, but it's enough. It's enough to tell it, I want to run this program right here, right? And then it runs it. Now, that's perfectly fine for what we're doing right now. We're just doing development, right? We're just doing development, and we see that it ran those commands. Now, there's something missing here, and in order to illustrate this, I am going to use a different interpreted programming language, Python. Okay? So let's make another program in Python at the same time. Or we'll be polyglots, as they say. And I'm going to put .py at the end of it just because I actually detest people who put suffixes in their scripts in Shell and Unix. There's no need for it, and it stops you from being able to change the language it's implemented in because it's got a suffix on it. It's really stupid. So don't use suffixes on Unix. It's a horrible idea. But in this particular case, actually, I'm just going to do that. How about that? You know what? Screw it. I'm going to make a new program. I'll call it hi. All right? I'm going to make a program called hi. And I'm going to say print hi. And this, by the way, is Python 3 and not 2. That's why I have these parentheses here, right? So what happens when I try to run this program? Okay, so /hi. Oh, we didn't chmod it, so let's chmod plus x. That's, you can see, can I just show you? I typed this so much. I typed chmod plus x so much that I have got an I can type it. I've got an alias called chmod plus x. So I have schmucks. If you can do it if you want. So I have schmucks./hi. All right, so /hi. What just happened? Pause the video, and I want you to take your best guess at what just happened. I'm going to run hello. Hello works, but /hi does not work. Why? If you can answer the question why, congratulations. You are really moving on to understanding how the command line works. All right. It is, the Python program didn't work, but the Bash program did. Why? The answer is because a program, if the computer does its best, or the Bash, in this case Bash, does its best to answer the question for you and help you out. So if you don't do anything to tell it what kind of language you want to use, it assumes you're going to write your program in Bash, because every single command you write is a Bash line, a Bash command line, right? So the assumption from Bash itself is that all of your scripts are Bash, right? And that's fine for now, but it's not very good if, like, what if you want to share your program with an idiot who's using Z Shell? It's a joke. It's a joke, okay? I don't have anything against people who use Z Shell. But, or you want to share it with somebody who runs, you know, whatever, TC Shell or something, right? Would your program work over there? No. So there is something, this is the, memorize this. There's this thing called a shebang line. A shebang, hashtag bang exclamation point. And the shebang line goes on the first line of a text file that you want to run. And we're going to fix this problem right now. So, and believe it or not, you can actually run Python as a shell, as an interactive shell. It's crazy you never do that, but you could do it. So how do we fix our hello program? Well, the hello program's not really broken until we try to run it someplace else, right? And it's really not broken because it's not using any special commands. But if I were on a shell that didn't have these commands, like let's say I use something that's a Bash only sort of thing, and I try to run that on a Unix system that does not have Bash, it would break, right? Unless Bash was installed. So we're going to add a shebang line. And the shebang line is the first line, shebang, exclamation point bang. And for right now, we're going to say bin bash. And if you don't know where Bash is, you can do which Bash, user bin bash. And this is always the part where I get asked the question, why not user bin env? And we're not there yet. We're going to go there. Okay. I'm not going to talk about that right now. Right now, we're just going to use this. Okay. And that says, so what does the shebang line do? The shebang line says, send every other line in this file to the standard input of this thing. So, and by the way, you can put other things in here. You can put -x or whatever. What it does is so now when this program runs, the very first thing the computer does is it says, do I have a shebang line? And it looks at these 2 bytes right here. I think it's probably 8 bytes, but it's not 2 bytes. It looks at these 2 bytes, and if it sees a shebang line, it's like, oh, I have a hint about what to do here. And so it says, run this. It runs that program. And then it sends every line after that to that program on standard input, like we did. Remember when we did it? Do you remember when we did? In fact, let's do it. User bin bash, and we pipe hello. So we're sending those instructions to the bin bash program. When the computer sees a shebang line, that is exactly the same thing that it does. If I wanted to, I could do -e, you know, or -x, or any of the fancy things that you can add. X is the one that we're going to learn later. It will show you, it'll give you kind of all the debugging while it's running it, right? It's exactly the same thing. So the shebang line is just a hint to the computer about what to send every other line to. And that's it. That's really all it is. And so now that that's there, as far as we're concerned, the hello program is the same. But watch how this fixes our hi program, right? So our hi program is now going to be fixed because that's not bash, obviously. So we're going to put a shebang line. Oops. And we're going to go see where Python is. Which Python? User bin Python. Okay. So user bin Python. All right. And you can save it. Watch what happens when you open it. The VI gets a clue and it's like, oh, cool. So now we can run /hi and it works. Even if it turns that off. The kernel, yeah, we're not. Yeah, you can definitely confuse them. Yeah, there's definitely there's things you can change in the kernel about how it interprets, these scripts of a way you don't want to mess with that, especially for a beginner. But so as you can see now, and by the way, that goes for Perl, right? I mean, if you wanted to, you could say echo. In fact, the Python code and the Perl code are identical. Isn't that cool? Hi and hi Perl, right? So you can do hi Perl here. Hi there, Perl. From Perl, user bin. I think it's user bin env Perl. I don't think. Do I have Perl installed? I should. All right. Hi Perl. Hi there from Perl. Oh, look at that. It didn't put a line return. That's interesting, huh? Yeah, I forgot about that. Perl has a command called say. Yeah, and that. Oh, god damn it. It doesn't. Is it say or tell? I think it's tell. Yeah, there. Damn it. This is not the latest version of Perl. Okay, we'll do print. So with print, you have to put a line return in Perl. Annoying as hell, but whatever. All right, there we go. So now we got a line return. We're going to talk about the USB hack, but I didn't want to confuse anybody. We have to start with the one step at a time, please. Everybody's anxious for me to teach you this next thing. Okay. Now you're probably asking about Go. Well, what about Go? Can I do that with Go? No. Why? Because Go is a compiled language, and when we get into our polyglot programming a little later, we'll start to do that. Okay. I mean, I don't know if you guys are ready. Do you guys want to do hello and Go too? All right, fine. Since we already did it, let's do it. Let's do. In this case, we actually are going to use an extension Y because it's going to get compiled. All right, so let's say hi Go, vi hi Go dot. You don't have Go installed though, do you? No, you don't. No, I'm not going to do Go yet because you guys have to go. You're going to get frustrated because you're going to try to install it. I mean, you could go out to the playground and do it. Let's try that. You want to do it in Go since you don't have Go installed? Golang playground. Go to the Golang playground, and you can try it. So there's your main package, right? Println hello. You see, there's a lot more stuff going on here. By the way, both Bash and Python and Perl, they have all of the same stuff. It's just hidden from you. So when you type one line, it assumes a main function body around it. It's pretty interesting stuff. That's what makes it so much easier for you to deal with, right? So here's a program. That's how the program runs, right? But you'll notice there's no shebang line here. Why? And I'll just kind of spoil it for you right now. So I'll do one for you just to get you kind of going on this. So higo.go, and I can say, hi from Go, just to make a point here, right? And I can do go run higo.go, and it seems like an interpreter, right? But that's not normally how you would do it. Normally you would build it. You would build higo.go, and it just builds it, and then it turns it in. Now we have, watch what kind of file type we get here. Higo. We get an ELF binary, and watch, you can even open it up. You might do it on accident. You're like, what the hell is this? Right? This is an ELF binary. This is the advantage of it being an ELF binary is instead of having to send every single line to the interpreter, binary compiled code like this can be directly injected into memory. And so it's extremely efficient. It doesn't have to be interpreted. There's no interpreter step anymore. It's been compiled, which means it can immediately run. The computer already understands this machine code because it's already been pre-compiled. So it just dumps it into memory and it works. I'm super paraphrasing, but that's effectively the same thing. And if, by the way, if you look at other programs like LS, you'll see these are ELF binaries, and stuff like that. So an executable is anything that can run on the system that has the executable permission set. Period. It could be an interpreted script. It could be a compiled ELF binary. It could be, by the way, you can't tell the difference between a compiled piece of Go code and a compiled piece of C code unless you're really good at like forensics, right? I mean, you can because, but at the fundamental level, all ELF binaries are created equal. I know somebody's going to crucify me for saying that, but that's true. As far as you care as a beginner, they are all machine code, and they will run on any system, on any Linux system that has your specific hardware. Period. You can take that binary and give it to somebody else. Now, I promise you, I'm going somewhere with this. Somebody's been talking to me about ENB. They wanted me to tell you the secret, but you really don't care about that until I tell you the next thing. If I want to share that compiled program I just ran in Go with my friend, and they have a Mac and they're running M1, and I am on, my Windows machine on Intel, I can't share it. Why? Because the hardware chipset is different, and different chipsets in computers cause binaries to be incompatible. They're at the binary level, they're incompatible. And I mean, there's LVM and there's a bunch of things that can get around that. But at the end of the day, this is why when you download code or games for Windows and they don't work on Linux, that's one of the main reasons, is because it's a different operating system, even though it's got the same chipset in that case. But sometimes it's a different chipset. And so when the computer's fundamental hardware, then the CPUs are totally different. When they have a completely different incompatible architecture, such as ARM, which is what runs, iPads and Macs these days, and you compare that to the AMD 64, right, which is the AMD set that it's based on Intel. Intel grabbed it from AMD, whatever. You're talking about different hardware chips, right? And the bottom line is that compiled code that I just made does not run on a Mac M1, period. There's nothing I can do to make it run over there, short of installing a virtual machine, but even then it's not going to work, right? Because it would have to be QEMU, which emulates the chip itself, which is really crazy cool, but it's hard to do that. So why would I, do that? Now, it turns out that with Go, I can actually compile this program so that it only runs on Windows, or that it only runs on, in fact, it's kind of cool. I'll show you. You can say Go equals Windows, right? And then I can build, and this, when I run this, it takes a bit longer because now it's building me a binary, hgo.exe. And now I have an executable program that will not run on this Linux machine. One of the coolest things about Go, I can't overstate this, is that it cross-compiles for any target architecture, which means I can make Windows code on a machine that doesn't even run Windows code. If I try to run this, it's going to be like, I don't know what to do. Can it? That's not what I want to do. But if I copy that file to my Windows machine, it'll run, right? It will even cross-compile for a different architecture. So if I wanted to cross-compile to ARM and Apple, I could do that. But what you end up getting, because this is pre-compiled code, you get a bunch of different executables. You get one per each type of operating system. And this is the time when I get to tell you that if you would rather not go through that hassle, you can run, if you're using an interpreter, you can run, Windows has a bash interpreter for Windows. Mac M1 has a Mac bash interpreter for Mac M1. And Python, all the interpreted code, the interpreter is the binary that is different. And therefore, those lines of instructions in the script, they're the same, no matter what. So the reason that when you go on the internet, you see a bunch of, Python and Ruby and Perl and Bash is because interpreted scripts, even though they're slower and they have to be compiled and everything, as long as the interpreter is installed, they will run without any changes whatsoever. But here's the rub. If I'm going to run my same program on a Mac, so let's look at the hello program, right? If I'm going to run this program on a Mac, anybody know where bash is on a Mac? Instead of absolute class, we're just using /. Okay, so does anybody know where, does anybody got a Mac right now? If you're on a Mac, I'm just going to tell you right now. Okay, if you're on a Mac, bash does not come on Mac by default. So if you want to get bash on Mac, it's a long story, but so if you're on a Mac right now, type which bash. Right. Okay. So it's either going to be the bin bash, or in some cases it's user local bin bash. In every one of those cases, though, we have a problem. So that whole idea about having one script to rule them all that runs anywhere is broken. Why? Because now when I share my script, I put it in GitHub, I send it an email to my friend, and they're going to run it. They have a Mac M1, and I have my Linux machine, and I want to share my script. Can I do it? They can't run it. They get it, and they try to run it, and it's like, it doesn't work. It says can't find user bin bash. Now, you know how to fix it, right? The fix is easy. The fix is you go into the script, and you change this top line to be wherever they're bash. You tell your friend, okay, buddy, go do which bash. All right. Mine says user local bin bash. Okay. Well, now go change go change the script and put user local bin bash at the top. Okay. Yeah. And so when they change it, but here's the problem. Let's say you make a new version of the script. You make a new version of the script and you give it to your friend, you email it to them, and they're like, I tried to run your script, you broke it, it doesn't work anymore. And that's like, and you're like, did you remember to change this shebang line? I'm like, oh yeah. Right? And after a while, that gets kind of annoying. After a while, run type bash my script. Yeah, that's another way you could do it. Yeah, my wife wants to talk here. Give me a sec. I gotta pause. Okay, so now you got a problem, right? Well, this is where, and you have to give credit to the Ruby community. The Ruby community is the first community that started doing this, and they discovered that user bin env. Env is a program. They discovered the use of user bin env to do this, and the first time I've ever seen it used was in the Ruby community, and this has become a new standard, which it's very controversial, particularly with the old guard like me, because it's not secure. It's got some problems. It's also less efficient, but it's more convenient. And let me show you why. When you run env and you hit enter, we're not going to get to find it, are we? Nope, we're not. When you run env, mine's kind of messy, so let's actually let's do that. When you run env, it will show you all of your environment variables. That's its main purpose. Okay, is to show you your modified environment. But it has a side effect. And what it can do, if you give it one argument, it will actually find that argument in the path and run it. So now I'm running bash, right? Watch what happens when I do Python. env Python. It starts at Python, right? So somebody found out that this has this side effect, and they decided to use that to save their friend from the hassle of having to tell them to update their shebang line all the time, for better or worse. And when you so the reason that this works is because user bin env is on every Unix system in existence forever. It does the same thing, and it's always guaranteed to be user bin env. Therefore, you can put user bin env here, and then you can put the name of the program to run, the interpreter, bash, Python, Perl, and Ruby, whatever. Yeah, sometimes you need to put Python 3 there. It depends on how new your Python is. It's one of the reasons that I don't like Python that much. The whole Python 2.3 debacle, which is completely asinine. Anyway, so you're gonna. People immediately told me to tell you to do user bin env bash, and I stopped because I wanted you to understand why. Okay, this is why they tell you to do this. Now, there's obviously a disadvantage to doing this, and there's an element of security involved, and I want you to be sure you understand this. By the definition of what user bin env does, user bin env looks for bash within, your environment, right? So, can you think of a way that I could make a program do the wrong thing? So, let's say I got access to this person's machine, right? I can put a bash program, and let me look at my path just to show you. I want you to understand this though, because it's very important. So up here I have a number of path items that are higher in priority than user bin bash, right? That's where bash lives. It lives way down here. So let's say that if I were hacking this person or I accidentally put it in there, I could put in, let's do this. Let's say tilde.local bin/bash, right? And this is going to get really messy, but I can put whatever the hell I want in here, right? And I could say that I wanted this to be user bin bash, right? And I could say echo muahahaha, and then exec bash this, and now I could do, now watch. Now we have to chmod it, or schmox it, chmod plus x. But now watch. Anything that I do, if I do hello, yeah, you see what just happened? You see what I just did? Do you see what I just did? I want you to understand what I just did. I just injected malware into the path, taking over the bash command. And in the old days, we were really, really paranoid. Not only did we not trust the path or env, but we didn't trust the environment variables even, and we would unset them all and set them correctly. But in this new age of like, who gives a shit? Sorry, people don't care about security as much as they used to, and they are really happy. They want convenience over security. And that would pretty much summarize the entire Ruby community when they came out. And I was a huge member of the Ruby community. I really loved it. But this is much less secure than this. What happens when I run this? Am I going to get hacked now? No. Why not? I want you to understand this. Make sure you understand this. If you're going to use user bin env, I have no problem with that. But I want you to know what you are signing off on. Okay? And if you and your friend are so annoyed by changing that one line of code every time you share a script with them, then yeah, maybe use user bin env. And I do. I use user bin env a lot. But if you want a more secure and a more efficient way, then just put user bin bash. User bin env, by the way, has to run env just to find the bash command before it even runs the bash command, which then has to read every line of your script, compile it on the fly, and then run it. And that, by the way, is a lot of time. That's a lot of time compared to, oh, you're an ELF binary, inject into memory and run immediately. And so one of the biggest arguments today is whether to use compiled languages, precompiled, I should say, or to use interpreted scripts. They both have advantages. One of them is super easy and flexible, and you can send text files around and all that jazz, but it requires that it have the right interpreter, and those interpreters can be taken over. There's no checksumming that thing. You just have to know what you're getting into, right? And so that's what I'm trying to help you make an informed decision. I am not against either of those methods. I use them both, but I just want you to know what you're getting into. And a lot of people won't tell you about that. They'll just say, oh, dude, why are you using user bin bash? That's like so old school. It's user bin env bash, dummy. Well, not necessarily, right? And now you know the difference, because now I'm hacked. I just got hacked. I hacked myself, but somebody was able to hack me by putting something in my path in the wrong place, right? And by the way, I need to remove that there. Am I doing the right one? I don't want to kill my interpreter. All right, so now it should be fine again. Right now it found the right thing. So now my path was not hacked. And now you understand how the path works. Now you understand how bash works. And I think we're going to end today. I'm so sorry we didn't, find, I've been talking about, we didn't do octal, we didn't do find. I kept pushing them off to the last thing, and we'll spend another couple hours on that, and then we'll write some more scripts. So we did more scripting today than I wanted to. So I don't regret it. I think it's probably fine. So, but I do need to end now. My voice is about dead, so I need to go. I'm kind of hurting. So anyway, does that seem like enough for today? It seems like something you can do. So here's the kind of homework I'd suggest you do. We did a little bit with chmod. We're gonna do some more for next week. We're gonna do what our base is. We're gonna talk about octal. We're gonna do find. We did access times, and I think we'll focus on that, and we'll start writing some more scripts. In fact, next week we might be able to write a tripwire script, which will show you all the files on your entire system that have been modified since a given time. And that's a really great way to catch a hacker. If that's how I caught the hacker who hacked me. So next week I'll show you how to write a script that is absolutely drop dead, impervious to hackers, that you will be able to catch every hacker who ever existed. Because nobody ever thinks to Trojan find. They Trojan ls and they Trojan the other commands, but nobody Trojans find. And you're going to know how to catch a hacker who's infiltrated your system. And I'll show you how to do that with the find command, and by regularly taking regular timestamps. And we'll start writing a script. We'll start a script. It's not going to be a big script, but it'll be the beginning of a tripwire script, which you can then go finish yourself. Okay, so and it's hands down the best way to find a hacker. I think everybody should be running one pretty regularly, and it's a fun project. Actually, it's a fun project. It's a very useful project, and you'll learn a lot about your system as you do. And it's a great way to find other hackers. By the way, if you this is kind of fun, but if you've ever successfully hacked a system, one of the things you can do is you can run a tripwire on that system to detect whether the system's been hacked by somebody else, and then you can find out where that hacker is, and then you can say, oh, there's another hacker over here, and you can leave him a message. Say, oh, hey, how's it going, buddy? So, it's not very common that you find that, but you can sometimes find that. So, and it's a very basic concept, but we'll go into it, and we're not going to get into the low level details. There's going to be a lot of parsing and stuff, but we've already covered that with grep, and so the baseline parts of this, and I believe in making scripts that are useful. So that's one of the scripts that we'll be working on. And I'm going to have to remember how to do everything from the one that I did from long ago, but it'll be fun. All right. That's going to be it for today. Thank you for your participation and your patience, and we'll see you next week.